Hi, welcome back to CodeJoy Coding Tutorials. I'm going to be showing the different ways to solve Roman to integer problem. I'm going to show the algorithm that I came up with in probably about 30 minutes, and then the correct algorithm and the difference between the two. So I went to LeetCode, so I remembered they had some good problems, and I thought I'd try to solve an easy one, just because I haven't done this in a while. And this is one that was kind of hard for an easy one. But anyway, um, the right is my code, which is super inefficient, and then the left is the problem. And the left says um, Roman to integer. Roman numerals are represented by these 7 symbols, and there are these exceptions, like an I before V equals 4, and I before X equals 9, X before L is 40. So basically, first part is understanding how Roman numerals actually work. For example, 617 in Roman numerals is DCXVII because D represents 500, C is 100, X is 10, V is 5, and the I's are 2. So you have 500 plus 100 plus 10 plus 5 plus 1 equals 617. Okay, and if I said 99, it would be XCIX. It wouldn't be um, IC. You might think it would be IC because C is 100, and if you put an I to the left of it, you subtract 1, so 99. But that's not how it works because I can only go before X or V. It's only in like the single digits. So in order to get to 99, you start with 90, which is 10 subtracted from 100. So this is XC is the 90, and the IX is the 9, because it's subtracting 10 from 100 and subtracting 1 from um, 10, so 99. Now, the way I solved it is kind of in the middle of efficiency. The stupidest way to solve this possible, the worst algorithm that still gets the correct answer every time, would be to memorize your Roman numerals and say, if like they give you 5 examples or test cases for you to work with, and if you were to put in your program, if S is III, return 3. If S is IV, return 4. If S is IX, return 9. If X is this, return that. You would pass all these test cases, but then when you hit submit, it would fail all the other random ones. So you have to build an algorithm that actually works. And so, for example, if you just did 1 through a million and put all the Roman numerals that you calculated into your algorithm and just had a bunch of if statements, that would be defeating the purpose of an algorithm because it's not going to tell you anything you don't already know within the algorithm. A good algorithm is something that you can understand how it works, and then at the end of it, you can say, Roman to int, this, like you can just put in a valid Roman numeral without even knowing what it is, and it will tell you what it is. So that's when algorithms become useful, is when you can understand how they work, but they can do things that you can't do, or do it faster than you can do. So um, when I was trying to solve this problem, first I start out by just saying console log s, and this is a function that takes in a parameter of S, which is a string or just letters basically. So when I'm calling the function at the bottom, I'm saying Roman to int of this. And this is my Roman numeral, and I want you to return the value of it. Now, so first things first, let's console log what we're taking in as the input and just spit it out as the output. That way when you run the code, it will say, this is what you're trying to do, and and at the end it gives you the answer. So first things first, I like to console log what it is, just to make sure my function's running and I know what it's trying to do. Then I start with a sum because I want to be kind of keeping track of the letters as they go, and then at the end I can just return the sum. And whatever these letters add up to be, that's the answer. So I create a variable and I started at 0. Um, Everything else is unnecessary and me like debugging my code. But it's tricky because if you're writing a program that's looking at the letters, for example, these letters that I'm inputting, um, let me break this down to here. Let's say I'm saying return II. The answer is 2 because the sum is 0, but when it looks at the first letter, it realizes it's 1 added to the sum and another added to the sum on the next letter, and it gets me 2. So what my algorithm is doing is looking at each letter in the word that I'm given and adding the correct amount to the sum. For example, if I did 3, it would be 3. Now, but what if I said 4? So it knows it's 4. It didn't add the 1 and the V to make 6 because that would be VI. VI is 6, IV is 4. So how does it know to do that? Well, you have to not only look at each letter, but while you're looking at each letter, you also have to look at the letter in front of it. And if this letter is in a special relationship with the following letter, this is how I coded it, then do something unique. Otherwise, just add them. So for VI, there's nothing special about an I being after a V. That's expected. So I just add the 5 and I add the 1 and I get 6. Whereas this is like a special case. It's rare. It's okay, there's an I and then a V next to each other. So I'm always looking at 2 at a time. And if I find a special case, I have an if statement saying, this 4 thing is saying go through it and then log it. So like log what you're looking at and log what's right in front of it. So I'm looking at the I, and I'm S, so S of I is I, and then S of I plus 1. The I stands for the letter that you're looking at. And it's V, so give it a value of 4. And this is bad code. This is just rusty me. not knowing how to solve this and just solving it with brute force, but still better than the totally dumb way to do it, because I can still get the right answer faster than if I already knew the answers. Okay, so basically what I'm saying is look at these edge cases, and if the I is before the V, or the I is before the X, or the X is before the L, and the X is before the C, if any of these are happening, change my switch to true, because I originally the switch is false. But then I'm saying go through each letter, and if the letter is ever an I with a V after it, or any of these cases, change the switcher to true and the increase to 2, and I'm just hard coding the value into it, because the special numbers are only 4, 9, 40, 90, 400, 900. So I figured it's okay to brute force that because it's not that much. It's like 6 instances. But otherwise, I'm saying if the switch is false, which means none of those things happen because I'm changing it to true in all those examples, then have our increase at just 1, meaning go to the next letter and add the sum. Whereas in these, I'm having the increase 2, because if I see a like let's say I did CD 12. The CD, the D is 500, the C is 100. So this CD combo is 400, and then the rest is 12. So it should say 412. And that's a combination of when the C is analyzed, it takes into consideration the D next to it. And because they're a special case right here, if the letter you're looking at is C and the letter above it is D, then it's 400. So I have added 400 to my total. Then instead of looking at the D now, I've already taken the D into consideration with the C. So I want to skip that letter and start analyzing the X. And at the X, I look at the next letter, which is an I, and I say, is that special? It's not. So therefore, I'm just going to add the X and move on. Is the I special? No. So I just add it and move on. I add it and move on. So as you can see, the value is 400. I have the sum at 400. Then it's 10. I'm sorry, it's 400. Then the X is not special because and then I just add it, and then I could console log it better to explain it, but basically, like for example, the problem is it's coded so weird that I would have to console log it in every single example. So I don't want to do that right now, but it works. And when solving this, I remember thinking, well, I'm gonna have to compare the. Let me get this out of the way. I'm gonna have to compare each time I'm analyzing a letter. I have to look at the letter next to it, and I have to be able to compare. Is C less than D? And a human can think to himself, well, C is 100 and D, and this is not code, this is just me like writing it out, and D is 500, therefore C is less than D. So that's true. Now, this is not code at all. This is pseudocode. But basically what I'm saying is a human can look at the C and the D and make a decision that C is less than D. But the problem is, if I'm trying to code, the problem I ran into thinking about this problem was um, like, what if I said at the end, the very end, what if I said if if C is less than D, console.log and it would be if C is less than D. Else console.log C is not less than D. See, it says C is less than D. So C is less than D. 100 is less than 500. But what if I said X is less than D? X is not less than D. Because X is greater than D in alphabetical order. But really, um, really, X is 10 and D is 500. So X should be less than D, but it says it's not less than D. So I foresaw this problem of, well, the Roman numerals are not in alphabetical order of value because X, which is would be the most valuable other than Z if that was a Roman letter, X is the most valuable in the eyes of the computer, the character of X, but D is has a low value in the computer's eyes alphabetically, but it actually represents a huge number. So how do I reconcile that? So I just tried to get around it, but a human, that's how a human would solve this. And humans are amazing at algorithms. A human would look at the C and the D and the X and be going letter by letter and saying, is X less than D? Yes, it is. Therefore, blah, 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 blah. So, I got around it by using these stupid edge cases and hard coding values of 6 different examples. But the correct way to solve it, after I solved it and passed, I looked up a video of how someone else would do it. And he did it in Python, but I'll convert this into JavaScript because I understand it. He made what's called a hash table, which is genius, basically saying, here are the values of the Roman numerals, computer. Because the computer is too stupid to know this, you have to tell it. You have to say, hey, I is 1, V is 5, X is 10, L is 50, C is 100, D is 500, M is 1000. Let's start there, computer. And the computer's like, okay, now I know what those letters are. And then the computer can iterate through the string and say, if the one, ignore that if statement, that just means don't go off the edge where it's undefined. When you're looking at I plus 1, that can get dangerous. But basically it's saying if the one letter you're starting with is less, if the value that we've given you here, if the value of the letter you're looking at is less than the value of the letter next to it, subtract it. Otherwise, add it and then return it. And so let's recode this. So this took me 100 lines of code and is very inefficient. So now, I don't know why it always puts me in 2021. It's like I can't escape it. Super annoying. All right, but let's say, oh, it's really frustrating how my folders are organized, but whatever. So let's say we have algo 2 now. And in this, I'm going to delete the whole algorithm. Okay. So again, to start off, I like to, just to make sure it's working, I like to say, you know, S is S. And then I will run the code. And it says S, you know, the Roman numeral of this, and also let's do one edge case, right? Like IX, for example. In the first case, it's, and then also another thing to do that I like is, you know, put a bunch of stars at the end of the function. That way, if you run it twice, you can tell. One second. Sorry, burning up. Okay. Taking the charger out makes my computer super hot. Okay. So S is that, and then the algorithm ends, and then I say we're running this one, and it says S is that. Okay. So it's not spitting out the answer yet because this is all I've written in the whole function. Okay. So now let's actually put some code here to solve the problem, because we want it to return a integer that explains what these letters mean. Okay. So first thing I'm going to do is make a hash table like that guy did. So I'm going to explain to the computer, hey, let Roman equal a hash table of when it's I, it's 1. When it's V, it's 5. When it's X, it's 10. And then we have 50, 100. There's one for 500. And there's one for 1,000. 1,000 is M for millennium. 500 is D for, I don't know, maybe deca millennium, like half. And then this is C for century. And then L would be, I'm not sure. But okay, so that is Roman numerals. Okay, so now it knows what Roman numerals are. So now I can say for let I equals 0, so we're starting I at 0, and I'm saying while 0, or while I is less than s dot length, you know, iterate through it. And just to show what this is doing, I can say hello s of I. Okay, just to show you what that does. I'm saying S is this is what I'm getting, and I'm saying hello to each letter. So for each letter, I've said hello to it. Hello C, hello D, X. I'm going in order from left to right. Um, that's what the for loop does. Okay, so now that I'm inside the for loop, any code I put here, I only put hello once, but it shows up for each letter. So now I can say if S of I is less than S of I plus 1, console.log S is less than its friend. Okay, and now I'll run that. Hello C, it's less than its friend. Hello D, okay, I'm a little confused here. Oh, I forgot to use the table. Okay, so Roman of, so if S of I don't want to be comparing S of I to S of I plus 1, because to show you what they are, S of I is S of I. S of I plus 1 is S of I plus 1. So when I say hello to C, I'm noticing that S of I is C and S of I plus 1 is D, and I'm saying S is less than its friend. Then for D to X, it also says it's less than its friend because alphabetically D is less than X, but we need D to be greater than X because we need to bring in this Roman hash table into play so that it looks at the value of the letter instead of just the letter. Okay? So that means I would say console.log value of S of I equals Roman hold on, press the wrong backtick. Okay, the value of S of I equals Roman of S of I. So when I'm looking at C, it knows the value is 500. When I'm looking at D, it knows, I'm sorry, when D, hold on, C it knows is 100, D it knows is 500, X is 10, and I is 1 and I is 1. We can't just add all those up though because S is less than its friend. We have to bring that into it. So let's say, instead of if S of I, let's say if Roman of S of I is less than Roman of S of I. Let's see if that helps. S is less than its friend because C is less than D because 100 is less than 500, so that's correct. Now the next time, now that is the only time that it should say that, and sure enough it okay, now I'm getting an error. I think it might be all these brackets next to each other is not working well. Oh. Okay. So when the letter when we're saying hello to C and its neighbor is D, S is less than its friend. The normal relationship is when it's greater than its friend. And there's just a bunch of normal relationships. So now I can get rid of all these. And I can just say if S of I is less than, I'm sorry, if the Roman value of S of I is less than the Roman value of the number next to it, then sum needs to subtract. So let's say let sum equals 0. And at the end, we can console log the sum. Oh, whoa. I don't know why my computer does that. And we'll return the sum. Alright, so if I ran it now, it would say the sum is 0 because I'm never adding to it. But let's say the beauty of subtracting the letter is in my other algorithm I was doing values like 400 and 40 and 90, but in this one I can literally just add up all the letters and then subtract the ones that are to the left instead of in decreasing order. So alright, so let's say when it's less than its friend, let's say sum is equal to sum minus the Roman of S of I. Otherwise, sum is equal to sum plus Roman S of I. So it's saying the answer is 1 for this. So let me console log the sum during the for loop. Let's see what's going on. Oh, I meant plus here. So sum equals sum plus Roman. So whatever the sum is, make it equal to what the sum is plus the letter. Okay, let's try again. Okay, so 412, that's correct. And 9, that's correct. Okay. Now we will try Roman to int of, let's say we had a C, what's that, 100? Let's do 117, that's a favorite number of mine. So 100, 15, 16, 17. And let's see if it works. So the string is this. There's a normal relationship, so we just add 100, and we're just adding, and it's not special. But what if we had to say 119? Well, as humans, we know we need 100, we need 10, and then we need almost another 10, but not quite. So it would be like this. That is, my human brain just calculated it. And now let's watch the computer do it. Wait, 100, 119. What happened? Okay, I don't know what the heck just happened, but alright, let's try that again. Come on. Okay. So, normal relationship, because 100 is more than 10. So we add the 100. When there's a normal relationship, we just go, well, in this algorithm, I don't have to worry about hopping twice or once. We just know that this number is being added because it's normal. This number is also being added because it's normal. Then the I, when we look at the I, it's not a normal relationship. It's less than its friend. So we go from the sum being 110 to the sum being 109 because we're subtracting that 1. And then we add the final 10. And it's a normal relationship. What if I ended on like a... I managed to not run into the problem of what if what if S of I plus 1 is undefined? Like, what if it's XX? Yeah, I'm not running into any problems. I wonder why he did if I plus 1 is less than the length, because I didn't have to do that. So mine might even be more efficient. I can't think of an edge case to break because the way I wrote it is I have a sum at 0, I have the values, and I iterate through, and I say if the first letter is, if its value is less than the second letter, subtract it, otherwise add it. So is, let's see this, if 100 is less than undefined, console.log 100 is less than undefined. I just need to see how the computer thinks about this. Else console.log else triggered. So the else is triggered, which means 100 is not less than undefined. What if I said it's greater than? So the else is triggered either way. So So 100 is neither greater than or less than undefined, which means that when we're looking at a letter, hold on, when we're looking at the X or the I to end it, it's saying if I, which is 1, it's saying if 1 is less than undefined, which it isn't, subtract, which it shouldn't because nothing's to the right of it. So there's no reason to subtract it ever. Otherwise, just add it. So we're always adding the last one in the way I've written it because of the relationship to undefined. So I don't think there's any Roman numeral where you wouldn't want to add the last digit because we're always subtracting like when it's 10, the sum starts at -1 and then we're always adding that last digit. Like even if what else could it be? Let's say 14. I'd say that'd be xiv. And the v is added on because the I was subtracted because we started at 10, we went down to 9, and then we got, so there's no scenario where it matters about having to get rid of that undefined stuff. So in this instance, I think I beat the guy in the video. For example, if I take the algorithm we've just written with our understanding of everything, copy this, and go back to LeetCode. Whoa. I don't know how my cursor just did that. What the fuck? Jesus Christ. Copy. Okay, what is going on? Like, I'm not allowed to copy paste? You turn into a fucking... What the fuck, dude? This makes no sense. Like what? I can't use the internet? This is the stupidest fucking thing I've ever seen in my life. Alright. Okay, that was the stupidest thing I've ever seen in my life. Okay, so let's run the code. It passed the example. Let's get rid of my console logs. That'll slow it down a tiny bit. Let's run the code again. So basically we have sum, we have Roman, which is a hash table or an object that shows the computer what the Roman numeral values are so that I compare the values and either subtract or add the sum. And then let's not console log this because this is business time. let's not even console log it. Let's just return it. So we're at 24 lines of code. Run the code again. All right, let's copy this just in case I want to save it. All right, now let's submit it. See if we break a record. So just for reference, my stupid algorithm an hour ago was like 7 times as inefficient. It was better than the way I solved it, just off of sheer will, was faster than 5% of other successful submissions that pass all the cases. This one that we just did is faster than 78%. Now in the YouTube video that taught me how to do this in Python, I do my history. His
This video
speed
that's
was 64%. So I beat him by 14%. So this was very good. Hope you enjoyed it. Hope you learned something about how to make an like this is just a comment here. It doesn't even need to be there. "20 lines of code. Look at that. 86% faster. 20 lines of code. Sum, hash table, iterate through, subtract it if it's like if you know how to use code, you can solve in 20 lines of code and 140 milliseconds what takes someone basically a full second, because 800 milliseconds is almost 1 full second. So it took less memory, and it's super fast, and great success. And last step is, let's take this beautiful thing and let's run Roman to int of C is 100. Let's do 499. So that would be 400 would be CD, and then 99 we would need 90 and then 9. 90 would be XC, and then 9 would be IX. So this should say 499. Unfortunately, it's probably not going to say anything because return is not the same thing as console log sim. Oh, return ends it, so you have to put the console log first. 499. There you go. Alrighty.